Okay, so we're going to fire this up from the surface of the moon, right? And we determined that this bullet goes up to a height of, we know that it goes 3.74 times 10 to the 5th meters above the surface before it stops, right? It's launched with 1,000 meters per second, but at some point between 1,000 and 0, it's got to be going 500, right? Okay, so at what point is it going 500 meters per second? Here it's going 1,000. How high is it above the surface when it's going 500 meters per second? Right, so what we'll do is we'll say kinetic plus potential here equals kinetic plus potential there. Okay, no way around that. So we're going to go minus g mass of the moon, mass of the bullet, right, over the radius at the surface, right, plus 1/2 mv1 squared, right? And that's little m, that's the mass of the bullet, right? That's going to equal minus g big M, the moon, right? Mass of the bullet. Over, we'll call this R prime, right? Because we want to know how high it is. We'll call that guy R prime, right? Plus 1/2 little mass velocity 2 squared. So this guy will be 1,000 to begin with. This guy will be 500 meters per second, right? Okay, now notice, I just want you to notice that the mass of the bullet cancels out of each term, so we don't have to actually do that. That makes sense, right? A bigger bullet would have more inertia, so it'd have more kinetic energy, but it would also be harder to remove. But it happens in the same proportion, so it goes away. So now we can just plug numbers in. Okay, so the opposite of g times over, and then it starts off on the surface, so 1.737 E6 plus 1/2 1,000 squared. It's weird not to have the mass in there, I feel like. Okay, let's see. Then the opposite, whoops, so that equals the opposite of g times 7.35 E22. This is what we're trying to solve for, is that height, right? That it's going this speed, so 1/2. Okay, let's figure this out. Okay. I'm going to figure out this entire left side just for kicks. All right. So the opposite of 6.67 E minus 11 times 7.35 E22 divided by 1.737 E6. Should be a big negative number. Okay, plus 0.5 times 1,000 squared. This side is negative 2,322,366.149. Okay, the opposite of G. Oops. There we go. R prime still what we're solving for. Then 0.5 times 500 squared is 125,000. That's positive. Okay, so I'm gonna actually subtract that from both sides. So this guy minus this guy is this. Okay, so now I've got, what do I have? I've got negative 244,736.149 equals opposite of G times 7.35 over R prime. I'm almost there, so I'm going to go this times this divided by this. I should have the right answer. Opposite of 6.67, E minus 11 times 7.35, E22 divided by the answer I just got. Okay. So now I'm getting that R. This is from the center, right? This distance that I just figured out here is this distance here. This R prime is from the center, and we got to figure out how far it is from the surface. So it's 2.003153 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th meters. So now the final thing, don't forget this. Okay, is I'm going to go 2.003153 times 10 to the 6th minus 1.737 times 10 to the 6th, because we need to figure out how high it is above the surface. So we have to subtract the radius. So that guy minus 1.737, 6 is 2.66153 times 10 to the 1, 2, 3, 4, 5. Honestly, these calculators, meters above the surface. For this is from the center. This is above the surface. Ta-da! Whoa, baby. That's fun, isn't it?